Alright, so the lesson today is 3.2 Pre-Calculus 30, and it's titled the Remainder Theorem. Now we're going to get to the Remainder Theorem towards the end of the lesson. So what I want to do is I want to just go over a few things with you that maybe you have forgotten. One of those things is polynomial long division. How many of you remember, I think you should have done this in Pre-Calculus 20, a long division. Okay, when you divide polynomials. Anyways, this is something that that we're going to look at. So let me just copy this into our notes. Okay, and the first thing we want to do here when we look at a division question is let's label the parts of this division question. So I have this also this little picture from I got off the internet here. So I'll move that up. Just as a refresher, okay. The divisor, the dividend, the quotient, the remainder. Okay, here's your traditional, right here is your traditional division question, long division you did in grade 5 or whenever you learned that. This 327 is the dividend. It's being divided by the 12. So you have the dividend here underneath well, it's the dividing sign. I was going to say a root sign. It's not a root sign. It's not the same as a root sign, okay? It's not square root. It's a dividing symbol there. But this is the dividend. This is the divisor. What you end up with here is the quotient, okay? So you've heard that word before. The result from dividing is the quotient. You may also have a remainder down here, okay? So those parts are important. We're going to be using those terms here in this lesson, and you need to know what they are, okay? So, if you remember how to do long division, it's been a long time for you, pardon the pun, long time for long division. But, you know, you take a look at this 327 and you say, okay, I've got a 2-digit number here, so let's take these two digits here, and 12 goes into 32 how many times? Well, it goes in 2 times, so you put a 2 up there. And what is 2 times 12? Well, it's 24, okay? Then you subtract to get 8. And that's kind of one complete sort of cycle there. Then you drop down this next number here. You put that down. Now it's 87. So now you start the cycle again, and you go 12 goes into 87 how many times? Well, it's 7 times. 7 times 12, 84. And so you kind of, then you subtract and you get 3. There's no more numbers here. So you can keep going. But when we do this division and you can stop at a remainder, that's the remainder there. Okay? So 327 divided by 12 is 27 with 3 left over. So 27 remainder 3. Or, actually, what you can say is the answer when you divide these numbers is 27 plus 3/12. We've got a remainder of 3, and that's actually a fraction of 12. So 27 plus 1/4. Okay, or 27 and 1/4. So that's kind of what we've done before, and at this, and I'm going to just zoom in a little bit here, I guess. Okay, so this right here is a polynomial long division, and I'll go over this real quick with you as well so you can remember. But if we have x squared plus 7x plus 17 divided by x plus 3, what you do is you, first of all, you kind of have to have all of the exponents represented here in the polynomial, all right? So if you've got a squared, x squared, that's where, if that's the degree, you have to have an x to the power of 1. If that term doesn't exist, you would add a 0x there, okay? That's important. It's not in this example, but it's important. You have to have all of the powers of x shown in this polynomial to do this correctly. So once we've got that, we're dividing by x plus 3, okay? Then you take a look at this x squared, and basically you're doing x squared divided by x. Or, this is the way I like to think about it, x times what would give me x squared. That's the way I think about it. I just think of multiplication instead of division. But x times, well, x times x would give me x squared, and so you put the x up there. So that x goes right there. Then you multiply, x times x plus 3 is x squared plus 3x. And you put it down here. So it mirrors this other long division, okay? So you put your x there, you multiply, and you put the result there. Then, just like over here, we subtract. X squared minus x squared gives us 0x squared. That's why it's not there. leave that out. 7 minus 3 is 4 x's. And then you drop the 17 down. It's a positive 17, so you drop that down. And you start again. X times what gives me 4x? Well, positive 4. And you go through the process, you get a remainder of 5. So when you divide this, the result is x plus 4, that's the quotient, plus a remainder of 5 over x plus 3. Okay, so there's 5 bits left. That's how you would act. That's how you would technically write that. Questions? Absolutely, we're going to do another example. Yes, we will. So let's just grab one here. Get to my textbook. We'll do another example of long division. So let's do this one. X cubed plus 7x squared plus 14x plus 8 divided by x plus 1. All right, so if we're going to divide this, what we want to do is we want to say, okay, x times what would give me x cubed, right? And so you put x squared. Now I like to, you don't have to, but I like to keep, sorry, all of the variables of the same degree in the vertical column together. They didn't do that in the text, they put the x squared over here. I like to do it this way. Keep everything, I just shift it over. So the x squared is on top of the other x squared. So you multiply and you get x cubed, right, plus x squared. Does that make sense? X cubed plus x squared. So you subtract now. X cubed minus x cubed, that always should be 0 here. That's the whole point. You're going to get rid of that. And 7 minus 1 is 6x squared. And then drop down that 14x. And that's sort of one cycle there, really. And you do it again. So x times what gives me 6x squared? Well, that would be a positive 6x. You multiply 6x times x plus 1, and you get 6x squared plus 6x. Subtract. 6x squared minus 6x squared, of course, is going to be 0. 14 minus 6 is 8x. Drop down the 8. And then you start again, and this is your last time through, I guess. So x times what would give you 8x? Well, 8. So 8 times x is 8x. 8 times 1 is 8. So we get this. And subtract, and you get 0. All right? You might run into, the question was asked, do we have to subtract here? Like here, do we have to subtract? You might run into some teachers or some methods that say when you get to this point, you can flip all the signs and add. It's the same as subtracting. So that's fine. If you want to flip the signs and add, then you get the same answers. Some teachers do that. I don't know. I just keep the subtraction here for long division. When we get to the next thing, the next method of doing this division is a little simpler. It's called synthetic division, and it involves adding. So there's that one little change there. But for long division, the way it's generally done is subtraction. Okay. All right. So what this means is that there's a couple things that this means here. When you take this polynomial and you divide it by this is the quotient. And there's a 0 remainder. So this is going to be next section, but what I want you to start thinking about is that if there's a 0 remainder, like if I do 12 divided by 4, right, like this, that means that 4 is a what of 12? It is a factor. Thank you. If there's a 0 for a remainder, that means it divides completely into this number. Okay, so I want you to start thinking about that as in terms of factors of polynomials, okay? Because that's what the factor theorem is. That's what we're going to do next. Okay, it's a little snapshot into the future there. But anyway, so there you go. That's long division, and we get 0 as a remainder here. Okay. So the answer, technically, if we talk about that format, is this plus 0 over x plus 1. See that? There's 0 parts remaining. So that's why we don't write that. We don't write that. Okay, so let's summarize so far what we've got as far as this format here. Let's go back to the textbook, and let's just kind of zoom down here and skip a little bit of that. So let's just dig into this right here. Okay? And this is what I've been explaining. The result when you divide a polynomial, that's p of x, so some polynomial, by a binomial. Okay, so we're going to stick to binomials, dividing by binomials here. What you get is, if the binomial is in the format of x minus a, which I'll talk more about in a second, you get this. The division is equal to the quotient function, which was, of course, what's up top here, right? This part up here. The quotient function plus the remainder number, so that's that r number, like this right here, in this case was 0, over the actual binomial that you were dividing by. So it's the little bits of this, right? And so that's sort of the, that's how you would express this long division and the quotient part, okay? Now, there's lots of different applications for this. Like, why are we learning this? Well, I'm not going to go through really another example with you, but what I want to get to is the fact that remainders are going to be very important, whether there's a remainder of 0 or a remainder of some other number. Okay, that's what we're leading to. So what I want to do is I want to show you, which I think is coming next year, I want to show you synthetic division. So here's some examples which we may come back to. But I kind of want to quickly move to this second method of long dividing that's actually quite a bit quicker. Okay, it goes quicker. And so students are really excited about synthetic division because it just takes a lot less time. So synthetic division is a method of performing long division involving a binomial divisor. So we're dividing by a binomial in the form of x minus a that uses only the coefficients of the terms, and it's a lot quicker. Okay, so let me show you. Now the textbook, I do have to put a little qualifier here. The textbook does synthetic division a little bit different than I do it. Okay, and I'll tell you the reason why I don't like the way the textbook does it. But if you want just a different look at it, once you've kind of explored my way, okay, once we've done this in class together, and you want to take a look at the way the textbook does it, that's great. Okay, always, if you have two different perspectives on the same thing, I think that's helpful. But when you're just learning it, I want to focus on the way that my method, which is kind of tried and true, is very, very similar. It's very the same. But, so here's the thing. The binomial is in the form of x minus a. Okay? Notice that there's a negative sign here. So that means that if I have x minus 5, what's the a value here? It's positive 5. So you might remember this sort of thing from all the transformations that we did, that really, if this was h, x minus h, the h value is the opposite sign that you would see there for the most part, right? So x plus 5, of course, has an a value of negative 5, okay? Now, this a value is going to be critically important here at the end of this lesson, because we're going to get to the remainder theorem, which uses a. It does not use negative a. So the synthetic division in the textbook uses negative a, which I don't like. Let's just get down to a. Let's use a, because that's what's going to be most important here going forward. So when we do synthetic division, and let me just kind of, let's see, I'll get rid of some of it. Okay, I'll get rid of it all. All right, and let's do an example with synthetic division. Let's go back to use one of the examples that we actually already did, shall we? So let's use this one. So what does that say? That says, and I'll just, whoops, get rid of that. So let's say x cubed plus 7x squared plus 14x plus 8. What you do with synthetic division, the first thing you do is you put an elongated L like that. Okay? Not a box, just put a long L like that. Okay? And what you're going to do is on the top row, and there's only 2 rows of this sort of container here. But on the top row, you are going to put the coefficients only. of all of these terms in your polynomial, including the constant. So I'm going to put, what's the coefficient for x cubed? 1, thank you. The coefficient for positive 7x squared is 7. Then we have 14. Then we have 8. All right? So once again, you want to make sure that you've got, and I'm going to clean this up a little bit here. You want to make sure that you've got everything, every term in this polynomial accounted for. If it's a degree 3, you have to have an x squared term, even if it's 0. You have to have an x term. You have to have a constant. And all of those numbers go in here. So if I did not have an x term like this, if this was the whole polynomial, this would be 0 here. Okay, that's important. And as you do more examples, you'll realize that, how important that is. Okay, so that's the first step. Elongated L, write the coefficients, kind of steps 1 and 2. Now what you want to do is you want to find out what your A value is. Okay, so x plus 1 is the binomial. What does A equal? -1. Very good. So we're going to put A right here. -1, just outside of that elongated L, and then we're set up, ready to go. Okay. So critical first few steps there. Elongated L, coefficients of the dividend polynomial, and then the A value of the divisor binomial. Okay. Now what we do, now this is just basically, it's taking how we do long division, and it's sort of like just recognizing a pattern, and we can kind of start to do things sort of a little bit quicker. So again, here's the pattern. The first thing you do is you drop this coefficient, you take it down, and you put it down here. 1. You just, whatever this is, you just copy it. Always. If you look back, oh, I think I erased mine now. But look at, this is a 1, this is a 1. Any long division you do, those are always going to be the same, so we can do that. That's a pattern that's recognized. The next step here is you multiply these two numbers right here, -1 times 1. You multiply, and you put the answer in the next column right here. So that is going to be -1, right? So you multiply and place the product right here. And just like long division, we have kind of a cycle that we're going to cycle through. So we're not quite done our cycle yet. Here we are now going to add these two numbers. And this is the only difference between the long division and the synthetic division. Here we get to add, which is going to be great. Okay, but you have to remember to add. And the reason why we're adding is because we're using the A value here and not the +1 that they use in the textbook. So if we add that, what do we get? We get 6. Very good. Excuse me. All right. Now that represents one complete cycle. Okay. So what have we done? Multiplied, put the answer there, added, put the answer there. That's one complete cycle. Now we do everything over again. So you go -1 times 6, and you put the answer right here. Then you add the column to get +8. Cycle number 2, done. Cycle number 3, let's give her. -1 times 8 is -8. And we add these two numbers and we get 0. All right. Now, this last number is actually pretty important. Do you know what this last number is? Yes, it's the remainder, right? If you remember, now I erased this, but the remainder down here was 0. So the last thing we're going to get is the remainder. Now, one other thing that I'm going to ask you to do is to box off this last spot here. And I actually do that before I even begin the process. I just box this off because I know that that's going to be my remainder. All right? And the cool thing about this is once you get into this, like it goes pretty quick, right? Like you can kind of imagine this goes really quick. And the other thing is this group of numbers right here are really important. What do you think that group of numbers represents? Look above. 1, 6, 8. 1, 6, 8. Those are the coefficients for the quotient. Always. And so you know that these are the coefficients. The only other question is, okay, coefficients of what? What's the x term? Right? Like x what? Here's how you do that. And again, this is a lot of information. We're going to do lots of practice. This was x what? Cubed, right? So your answer, this is going to be a coefficient for x squared. You always reduce it by 1. That means that this is the x term, and that means that this is the constant term. So we have positive 1x squared plus 6x plus 8. And this is your quotient. Okay, so we have x squared plus 6x plus 8, remainder 0, or plus 0 over x plus 1. And remember, the binomial was x plus 1. We use the a value of -1 in our synthetic division. Okay, any questions there? You're all going, I don't know if I have questions. That's something brand new, okay? Yes. All right, here's another example that we're going to do. And here we have a polynomial, and here we have dividing by a binomial divisor. So we're going to be able to use synthetic division. And again, long division, there are not really too many times where I'm going to make you do long division now. It's just going to be synthetic division, because you're going to have to be doing a lot of it for different questions as we move forward. So synthetic division is what I want to hammer on today. Now, what's the first thing you notice about this question? Anything you notice at all that looks a little bit different? Yeah. Okay, very good. The powers of x in our dividend are not in order. Now, do you think that's going to make a difference when we do synthetic division? Does it matter if they're in order or not? What do you think? According to our first example, because you've really only had one example, were the coefficients in order of descent? Yeah, they were in descending order of the variable. So it actually does make a big deal. If I write down 5, 10, -13, and -9 for my coefficients, that's going to be a different answer as if I do this, right? That's going to be we're going to get a totally different answer. So yes, the order does matter, and this is the order that we want to write these in, okay? So just for those of you that maybe missed that last thing that I just said, you actually want to make sure that not only do you have all of the powers of x accounted for, they also have to be in descending order of the variable. And of course, this is x to the power of 0 there, really. Okay? That's very important. Okay? Descending order of the variable. Okay, so I've written down my coefficients now. Where's my elongated L? It's right here. Under the last number, I'm going to put a box. Okay? So that's how you get your synthetic division started. And I have to figure out what number I'm going to put outside here, right? If it's x minus 2, what is the a value for this binomial if this is an x minus a format? Positive 2. Very good. So I put a positive 2 there. Everyone see that? Okay, so now you've got your synthetic division set up. Now let's go over that process again. First thing I do, drop the 5. That's always the first thing. Just drop it right down. Then we multiply. Then we put the answer right there. So 2 times 5 is 10. What do we do with the columns? We add them. So what do I get? -13 plus 10 is -3. Very good. So that's one complete cycle. We're finished. And now we do it again. 2 times -3 is -6. I put the answer there. And I add 10 minus, or 10 plus -6 is the same as 10 minus 6. That is 4. Okay. What's 2 times 4? That's going to be 8. And if I add this, I get -1. All right. So what does this tell us? Well, it tells us a few things. It tells us that we have a remainder of -1. It tells us also that we have coefficients for our polynomial here. And we started off with a cubic function, right? So the answer is going to be a quadratic. See, that's going to be squared, that's going to be x, and that's going to be your constant. So the solution, actually, if we write everything out, if we write everything out, the original polynomial was, so here's our answer, it's 5, oh goodness, okay, so 5x cubed plus, or sorry, minus 13x, and you can write it the other way, I guess that was in the original question, but I'm going to write it this way, plus 10x minus 9, and if I divide that by x minus 2, this is what I get. I get 5x squared minus 3x plus 4 as my quotient, and I add to that -1 over x minus 2. What did I forget? Oh, squared here. Yeah, thank you. That's right. So this is, that should be, right there, that should be your solution in the format that we talked about earlier, right? I don't think I wrote it down here, but it's in your text. That format that I highlighted. Yeah, so see right here? That's the question right there. So that's the format that they may ask you for, okay? All right. Any questions so far? If there's no other questions, I'm going to give you a synthetic division problem to work through and on your own, and then yeah, we'll see if you can, how you can do. So let's do something. Let's do something fairly simple. I'll get one here for you. Okay, so here's an example I want you to try on your own. X squared plus 10x minus 24 divided by x minus 2. Okay, so see what you can do there, and do the synthetic division and give that a test. See what you get. All right, when you're finished, you can check up the board there. How many of you got x plus 12 as an answer? Yeah, very good. Now listen, I know that you probably looked at this and said, you know what? I know x minus 2 times something else to give me this. I know what this is because I've been paying attention to math class, and I know that I need two numbers that multiply to -24 and add to 10. And so this is going to be x plus 12. Because 12 times -2 is -24, and 12 plus -2 is 10. Yes, that's very good if you saw that. But obviously there's going to be some tougher questions that you won't be able to solve kind of just by sight, right? But yes, that would be your check. The check would involve taking this number that we're dividing by and multiplying by the quotient. And if you get the original question back, of course, if the remainder is 0, right? If you get the initial question back, then you know you've done it right. And even so, if you get a remainder, you multiply these two and add this remainder, you should get exactly the same original dividend back, same polynomial, okay? So that's how you can check. And of course, if you do FOIL here, you certainly do get the original polynomial. You good to go? Okay, that's synthetic division. The final part of this lesson is what is the remainder theorem, okay? So something interesting here that you probably, with these few examples, you probably haven't figured out yet, but there's a something neat that you'll be able to find. You'll be able to find out what the remainder is before you even do any division, okay? So here's our remainders, right? So you would be able to detect these remainders without doing any division at all. And I'm going to show you how to do that, okay? And that's called the remainder theorem. So I'm just going to get, maybe we'll get a couple examples here, okay? Let's just write this down here. I'm going to show you something. So here's a few of the examples that we did today. The dividing the polynomial divided by a binomial, and I've also noticed what the remainder was. Not the fraction, actual remainder, but just what this number was at the bottom. So you see all these here, and I'm going to show you the connection here. If you take the a value, so here a equals -3, okay? If you take the a value of the binomial divisor, and you put it into the original function for x, what do we get? So this is -3. What if we did -3 squared plus 7 times -3 plus 14? What's that? That is 9 minus 21 plus 14. What do we get? 2. Did I write that down right? I don't think I wrote that down right. Look back in your example. Did I make a... This is 17? Rolf! You corrected me! Oh my goodness. Okay, thanks for messing up my entire example right here. That's terrible. Okay, so let's try it again. What happened? I lost too much there. Okay. You're forgiven. Okay. All right, let's change this to 17. Now, what do you get? You don't get -2. You actually get what? 5. Thank you. That's what was supposed to happen the first time. Okay. All right. So let's check it out. What's a? A is -1 here, right? -1. So what happens if we put -1 in here? -1 there, -1 in there, and -1 in there. Well, I'll just do it quickly over here. That's going to be -1 plus 7 minus 14 plus 8. Okay, so 7 and 8 is 15. -1, -14 is -15. You add all those up, you should get 0. Are you recognizing a pattern here? Okay. So if we plug in +2 here, that's 2 squared plus 10 times 2 minus 24. That's going to be 4 plus 20 minus 24. And that's also going to give us 0. That's the remainder as well. So the remainder theorem states that if you have a polynomial and you divide by a binomial, that P of A equals the remainder. All right? So P of X divided by X minus A, okay? When you do this, a polynomial divided by a binomial divisor, okay? P of A, that is when you evaluate the polynomial with A in there, equals the remainder, or at least the number of the remainder, not the whole fraction, but the remainder part, okay? So that's technically the remainder theorem there. So I'll just bring that up in the textbook. Okay, let's see, remainder theorem right here. This is what it is right here. States that when a polynomial in X, that's P of X, is divided by a binomial in the form of X minus A, the remainder is P of A. All right, and this is actually going to become very important in our next lesson when we talk about the factor theorem. Okay, so knowing what the remainder is ahead of time without doing all the work is going to be quite useful to you. So here's an example real quick. You don't have to write this down, but if we have a polynomial here and we divide it by this, of course A is -4. So if I plug -4 into the polynomial, I get -4 cubed minus 10 times -4 plus 6, and I get -18. And they did it here through synthetic division, of course their little version. But the point is they get -18 as well for a remainder. So this remainder theorem holds true. Here's your key ideas just to round off the lesson if you want to take a quick look at that, and I will give you your assignment. Right.